Okay, so Elena's question during her presentation was, what are some examples of strategies you could provide to participants? So these are some of the responses that we got. So I think there's a couple of elements to this. First of all, with neurofeedback, a lot of it can be very personal and it can be very individualized. So it's usually better to have some structure in place so that you can actually get participants' responses themselves, like asking them what might be the most positive memory that they can think of. So that's the first thing, is that it can be very personal, it can be very individual, and you actually don't know that if that memory that that participant thinks is the happiest that they have, you don't know how well that's going to correlate with brain activity in the scanner. So you need to ensure them that to be flexible, to try those sort of main, say, 3 strategies that the researcher has discussed with them outside, to try those 3. But if they don't actually change the thermometer, they need to change something else, because at the end of the day, it is a neurofeedback task. It's not an autobiographical memory task. So you're trying to use autobiographical memory to change the thermometer. But if those memories don't work, they should try some other strategy. And they can be pretty surprising. Like, I've been a pilot for Elena's scan, and I was trying to recall, like, going surfing at the weekend, trying to get real into whatever positive memory I had. It didn't work at all. But the minute I would stare at the thermometer and just repeat to myself, happy, 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 that was actually making the thermometer go up. But that's not something you can tell a participant before they come in, to be like a maniac and look at the thermometer and just repeat happy. But that worked for me. And I think that's the beauty of neurofeedback, is that you can find yourself those personalized strategies.
Yeah, just adding to that, if do you have any sort of experience with emotion regulation and these strategies that you've already mentioned, it could be also good to hear more from you, and if you had any experience with like a experiment related to these for emotion regulation, so we can have a bit of more chat even now, or like after the session, for any strategies that you might actually suggest for the study could be good.
And so this is just a quiz for our recapping our final session, and after the quiz, if there's any questions, otherwise we will finish up here. But if you can just go through and answer these, I think there's 5 questions. Is it not working? Oh no, that's weird. Yep, all at the same time. Ethan, do you want to respond to this?
It's behavior.
Yeah, so the correct answer was behavioural here. So I think Ellen is referring to a behavioural only control group that's outside of the scanner. If it was a strategy only while they're inside the scanner, you could also potentially look at placebo effects or motivation for being inside the scanner. But if it's outside the scanner, you can only really account for behavioural effects.
Does anyone on the panel have comments on?
Yep, it's all of the above. Yeah.
It's all of the above.
It's all of the above, yeah.
Okay.
Yeah, so the correct one was transfer for this. But I think as a caveat to that, if you are going to include a transfer run, you also need to compare it to something else. So you need to have a baseline run to compare that to, ideally. And they're supposed to be the same task. So ideally the same task without neurofeedback before the neurofeedback session, and the same task after. And then you can assess learning effects.
I think some of the people on this stage have selected these folders so many times they've probably got them tattooed on their skin somewhere or something. They probably go to sleep dreaming of, or nightmares I should say, not dreams.
Yeah, so maybe it's better to say what are two key TBB files, and it was actually, yes, .rtp, which was the person signal change of our target and confound region, and .prt, which was the protocol file, which was the onset and offset of the duration of the conditions.
I think Ethan will be happy with this.
Yeah, so thankfully, most people got this wrong. For us, it hasn't been investigated in cannabis users yet, so that's where we come in, and that's our sort of novelty of our group, is that we're investigating in cannabis users for the first time internationally.
And that's the end of our quiz. So I guess we're getting right to the end of the session. 6 minutes left. While we've got all of us here, I know there's not many people left. We've disintegrated over the 4 hours, but that's understandable. Does anyone have any questions? Yeah, thanks.
Thank you all for your talks. I was wondering if neurofeedback has ever been used in more naturalistic paradigms, like movie watching or something like that. And if you can talk a little bit about how then that would affect of doing multiple runs of like watching the same stimuli. Thank you.
Yeah, so it has been used, at least from a substance use cohort perspective, it has been used. There was a team, I think they used in nicotine, as far as I know, like tobacco smokers. But yeah, they basically presented a video and they changed the opacity of the video. So instead of a thermometer going up and down, the brightness of the video changed depending on their feedback scores. In terms of how they controlled for that after different runs, I'm not exactly sure, because there's obviously going to be memory effects then from showing the same stimulus over again. I guess a potential solution is the same thing that we do for visual stimuli, is that we show different visual stimuli each run. So for us, there's pictures of cannabis, but the same picture of cannabis is not repeated for a different run. So I guess the same principle would hold for like a video of the same type. They might show different videos over different runs.
I think another way you could do this is have the baseline and transfer as a naturalistic stimuli. So basically at baseline you show them a movie, and then you go through the neurofeedback training, and then at the transfer you show them maybe a different movie. And you can randomize the movies across participants. But then the idea would be, has the training helped them regulate emotions better in the context of naturalistic, like a movie? Like while watching a movie, if there's a scene which has something emotional, is their brain activity or even is their response different after training compared to before training? So I don't think that's been explored as far as I know, but it's an idea that could be explored, yeah.
Hi, I've got a got a situation that I'm not sure what to ask you in terms of the question. So we're trying to replicate the FMRI studies on Parkinson's patients. But the challenge is, of course, is that they either, how do you account for movement artifact? How do you essentially replicate what is a cortical variability that essentially occurs as a result of that disease process? So we've been trying to think outside the square and thinking EEG with CT and all those kind of things. The end target for us is to do it with neuronavigated RTMS. So that's the reason why we want the MRI as well as the functional map. Have you guys got any thoughts or what you've seen internationally, anyone, that how we can, because we're starting to bank up a whole queue of Parkinson's patients wanting RTMS, but we can't do an FMRI. So what are your thoughts?
So your question is mainly to try to figure out a way to localize a specific region accurately for Parkinson's disease, given their head motion and tremors.
Correct, and then also the cortical variability.
Cortical variability, right. Yeah, it is a tough question. So in terms of TMS, at least in depression, there is an ongoing trial as well where they have methods to personalize the target. Now I'm not sure if you could potentially discuss with them and adapt that for Parkinson's as well. But of course, you've got an additional layer of cortical variability, whereas in that one, it's more functional variability. Another thing that I can think of is kind of trying to do deep sampling. So deep sampling in the sense you have one participant go through several scans over many days. And so you would kind of have, you'd kind of emerge with a target that is individualized for the person over time, because you would be scanning the same person over time. And so you could have RTMS maybe after 5 scans. So you have 5 scans and you've got like more data to kind of, so you don't have to compare between subjects, but rather within subject. So you could explore those, but of course it's not necessarily related to neurofeedback as such. But these are just general ideas that I have, yeah.
Have you seen anything convincing to the same grade as an FMRI on EEG or any particular outpatient EEG solutions?
I think with EEG, there is source localization. So sometimes what people do is they measure MRI, structural MRI, and then they measure EEG, but then they can use source localization algorithms to use the structural MRI as a foundation to localize the probabilities of where the EEG signal might be emerging from. Now here you could do 7 Tesla. So if you do 7 Tesla structural MRI, you would have much higher kind of anatomical resolution that could improve your source localization compared to a 3 Tesla MRI. But yeah, other than that, yeah, that's pretty much where EEG is at. It's difficult to localize. You could have electrical signatures, but if you want anatomical, I think EEG is not there yet.
And the 7 Tesla under sedation.
7 Tesla would be your best bet in terms of, yeah. And
Actually, can I ask about that? How severe are their tremors when you can say MRI is not possible? What type of, what condition are these participants in?
It's a good question. They're varying conditions. Some of them have tremors that are not conducive to basically staying still for any particular period. So that the 7 Tesla we might get away with that. The others have had torticollis as a result of their Parkinson's, so it's more unable to fit within the MRI scanner because they're bent over like a comma. So it's a variety of different challenges getting them into a scanner, essentially. So. And
you're looking at this as a robust treatment option. It's not like you want to research 10 people with Parkinson's. It's a long-term.
It's a long-term play.
Sure.
Yeah, absolutely. So we have a next stim in our clinic, which means that it's got a 3 millimetre tolerance with regards to anatomical localization, which makes it challenging. But we're looking at all solutions from around the world, whatever would essentially will help us put this trial together. So.
You could also look at the DBS literature, deep brain stimulation,
That's
because they've got very good results with Parkinson's.
Yes.
Could look at some work by Michael Fox as well.
Yes, love. Yep, thank you.
Yeah, thanks.
Thanks for a great session. And I have a question. Have you experienced that someone is not responsive to the neurofeedback? And what do you do with that? Can you identify these individuals early in the events?
Yeah, I think that's a very good question, because we do see a lot of people that it just doesn't seem to work. And I think the reason for that is still out there. People don't really know why that is the case. There has been some research that have correlated it to even personality type. So there's one paper that looked at like openness and sort of agreeableness that can positively correlate with, and if you higher susceptibility to anger and like frustration, actually negatively correlates with. But yeah, other than that, things like arousal, motivational effects, they're probably all contributing as well. But yeah, personality seems to be a potential explanation, but yeah, still remains out there.
Yeah, and this question is quite open still, so it's a very fertile area of research, I would say. I think the other aspect would also be dosage. Some people might need more sessions to start seeing effects, where some people might be quicker. It also depends on whether the person is able to kind of detect or be aware of how the strategies they're using links up to the signal that they're seeing. So that awareness also kind of builds with practice and time. In general, if you look at the EEG neurofeedback literature, people tend to have many sessions, like 20, 30 sessions, which is a very normal thing to do there. So with fMRI, we're kind of constraining it to a few sessions. So yeah, dosage, I think, is another aspect of the variability.
Yeah, and just quickly to add on this, so that's why the pilot scan also is very important. So if you find your design and have 100% people is not engaged at all, there also it's a learning from both direction, from the participant and then the experiment design and then the backend setup as well. So yeah, so probably have both of the parts, just try to underpin what is behind it, and a lot of post-hoc analysis that what Amir is showing, that we see whether the activation is activated after the scan, especially for those people failed. So that's a really good question, and it's always push the whole project is progress and develop. Yeah.
Yeah, Joe already mentioned, look, there is also so many technical considerations behind this, and what we are calling feedback and what we are showing to participants, you need to cross-check, double-check, triple-check, where does this actually coming from? For example, does lower number of voxels might be a reason that you see more noisy feedback? That if you see more noisy feedback, that's not an actual feedback of that region, that goes to the participant. So it might also result in a not successful neurofeedback session. So I would say all these technical steps and considerations are also important to just double check and see whether it's the best thing that you need to do. Even about, you remember I said about distraction. So we made the feedback weighted. Or for example, Sampras is using intermittent feedback, and of course he knows better about it. Or using continuous feedback for every experiment. All of these might make sense. We had this discussion the other day with Ethan that, for example, maybe when it comes to emotion regulation, maybe, it might be better to not only focus on continuous feedback, but also think about intermittent feedback as an option. Because every 1 second you want to update that feedback, although they are still thinking about that positive memory. Or maybe they want to just close their eyes and think about that positive memory. Is it better to just provide a, variable instruction whenever they need to look at the feedback, let's say every 30 seconds? All of these might make sense in this case, I would say.
Okay, thank you so much.
Thanks. So I'm aware that we've gone 5 minutes over. Does anyone else have any questions? No? That doesn't mean you can't ask questions. I'm just conscious of keeping you here. So no more questions? No. Okay, so in that case, I think we'll close the session and say thank you so much. There's a few of you that have been here the whole time. That's really lovely. And thanks for the questions and the interactions. The team here are always really happy to chat about neurofeedback, as you can probably tell So, seek us out if you've got any other questions. And we also, there's like a couple of other bags of koalas, so everyone can get one on the way out. Thank you.